Assalamualaikum warahmatullahi wabarakatuh. So today we are proudly presenting for a CHM256 video presentation with the title of Volumetric Analysis, Analytical Evaluation of Free Fatty Acid Content in Used Cooking Oil. So first thing first, I would like to introduce to our team member. The first one is me, myself, Husaini bin Syadani. Then we have Amirul Daniel bin Muhammad Rizwan, Abdul Alif bin Ahmad Subri, and Muhammad Daniel Mukris bin Azman. Alright, without further ado, I will get straight to the introduction. So, volumetric techniques determine concentration by measuring the volume of solution required for a reaction, typically using pipettes, burettes, and titration. Other than that, titration analysis is essential for determining the concentration of substance and evaluating their purity. So as we know, there are two types of titration, which is the first one is direct titration and the second one is back titration. So the direct titration is when the titrant is added directly to the analyte until the endpoint is reached, while back titration is an excess reagent is added to the analyte first, then the remaining excess is titrated. So in this experiment, in this presentation, we are using the direct titration.
Before I explain the theory, let me ask you a simple question. Have you ever wondered why cooking oil become more darker and smell bad after being used many times? This is answer related to something called free fatty acid or FFA. Normally, cooking oil is made up mainly of triglyceride. However, when the oil is exposed to heat, water or oil during cooking or store, the triglyceride begin to break down through a process called hydrolysis. As shown in this situation, one triglyceride molecule react with water to produce glycerol and 3 free fatty acid molecules. The longer the oil is used, the more free fatty acid are produced. So, how do we measure the amount of free fatty acid? We use a titration method with sodium hydroxide or NaOH. During the neutralization reaction, the free fatty acid react with sodium hydroxide to produce soap and water. To know what the reaction is complete, we use phenolphthalein as the indicator. It is colorless in acid solution, but all the free fatty acid have been neutralized. The solution changed to pink color. The pink color that we have reached the endpoint of titration. Next, we use this formula to calculate FFA. If the FFA value is below 0.67%, the oil is considered fresh and good quality. However, if the FFA value is above 1.5%, it means the oil has been deteriorated and its quality is much lower. Next, we go to application in food industry. Food industry use the method to identify or detect residuality in used frying oil. This method used to identify oxidation and spoilage in repeatedly used oil. Next, it helps determine whether oil is safe for consume. Is to decide if oil is safe consume, continue to be used or should be discarded. That's all for me. Thank you.
Now, for the adjective, it is very simple, which is to determine the percent of free fatty acid FFA content of a used cooking oil sample using NaOH titration.
So the next procedure. The first step is 5 grams of palm oil sample was accurately weighed and transferred into 250 ml aluminium flask. The second step is 100 ml of neutralized ethanol and a few drops of phenolphthalein indicator were added. The third step, the mixture was shaken to dissolve it completely. The fourth step is mixture was titrated with 0.1 N NaOH and was shaken until the endpoint is reached, which was indicated by a slight pink color that persisted for 30 seconds. The fifth step is the volume titration used was recorded. The sixth step, step 1 and until 5 were repeated carefully in triplicate. Each weight of the sample and the volume of titration were recorded.
Next, I'll present the results obtained from the experiment. As shown in the table, 3 palm oil samples were analyzed. The masses of the samples were 5 gram, 5.03 gram and 5.01 gram, which are very close to each other to ensure consistency. For all three samples, the initial burette reading was 0.0 ml, while the final burette reading was 3.6 ml. Therefore, the volume of 0.1 and potassium hydroxide KOH used for each sample was 3.6 ml. So for the conclusion is the percentage of free fatty acids FFA in the oil was determined using titration and found to be approximately 1.838%. This indicates a relatively high level of hydrolytic degradation, suggesting that the cooking oil is in high FFA and determined to be a lower quality oil. Thank you.